Hello everyone, welcome to the live class. So guys, today we are having another live quiz session and we are going to discuss some of the very important questions of quantum mechanics in today's session. So first of all, let me know, is everything all right? The audio, video, slides, everything is fine? Or is there anything like not clear to you? If this is gonna be the case, please let me know in the comments. And then we are quickly going to start the discussion. So I'm just going to check your comments here. Is everything all right your side? Audio, video, slides, everything fine? Just let me know in the comments once. Okay, that's good guys. So we are going to start the discussion about the questions, but before that I'm just going to let you know about the Unacademy Plus subscription, and then we will quickly start the discussion about all the questions we are going to consider in today's session. So as you all know that now we are just having less time remaining before the exam, and as per the official notification we can have our exam most probably in November. So now this is the time to start the revision and to just complete everything. Okay, so revision sessions on Unacademy Plus will start soon, so that you all will be able to attend these sessions and you will be able to do the revision in very less time with all the top educators we are having on Unacademy Plus for your upcoming exam preparation. Along with that guys, there are going to be so many batch courses going on. Okay, so this one which has started in this month, but after this, like, you are going to have a new batch course which will start on 1st October. So this is your upcoming batch course. Okay, and if you want to attend the live classes of this course from the starting and you don't want to miss any of the sessions, then you can take the Unacademy Plus subscription, and all these courses will help you a lot. Also guys, when you are going to take the Unacademy Plus subscription, you can use and apply the referral code, that is Anjali Arora, as it is mentioned here. Okay, spelling should be same, no space in between. That's how you need to write it and apply it. And by applying this referral code, you will get the 10% discount in the total Unacademy Plus subscription amount. Also guys, there is another referral code, that is AnjaliALive, as it is mentioned here. So you can even use and apply this one. Both will work, but at a time you can use any one of the referral codes. Okay, so any one you can use and apply to get the 10% discount in the total Unacademy Plus subscription amount. Now we will start the discussion about the questions we are going to consider in today's session. Along with all these information guys, one more thing I would like to tell you here, that is about the special classes. Okay, so now today at 7:30 we will have our mock test analysis session, the championship mock test analysis session. That's a special class. You can attend that session. So if you are going to attend the championship mock test, you will have the link for attending those tests. Okay, there you can even get the link to attend the live session or the special class in which we are going to do the analysis of the mock test. Another thing is, our another special class will be tomorrow. Okay, so that's again gonna be because tomorrow we will not have our this session, that is the live quiz session. So at 3 o'clock we will have our special class. Okay, so you can join that session. And now our upcoming YouTube sessions will be in next month. Okay, you will get to know about the complete schedule for that too, the timing and everything, so that you will not miss any of the sessions. Okay, now let's quickly start the discussion about the questions we are going to consider in today's session. Now guys, here we are going to have, like, as you were facing difficulty in reading the things, okay, when I was just using this like these slides, so we are going to have this kind of format, the writing you are going to get. Okay, so I'm just going to show you this one, as well as there is one more option, so I will show you that one too. If you will find that more convenient and more better, then we will use that one. Okay, so I will just show you. So here when we are going to write, it's like this you will get. So let me know, is it properly readable, and you will get to know about everything. Whatever I will write, and I'm going to show you the question on the screen, or you want me to consider a little more darker pen if it is not readable and clear. So firstly confirm this. Is it readable? Is it clear? Done? So we can continue with this one. Otherwise there is one more option, like we can use that too. Clear? Okay, so let's continue with this one only. Done? And I'm just going to give you your first question for today's session then. Okay? Done? Okay. So guys, here is your first question for today's live quiz. The question is in such a way that you are having a wave function at time t is equal to 0 given to you. Okay, there is a wave function given to you at time t is equal to 0. And the expression for the wave function is 1 upon root 15 2 psi naught x 2 psi naught x, okay, minus sine 1. Clear? Now what do you need to do? You need to write the wave function expression at any later time t, and the options are like this. This is the wave function at time t is equal to 0, and the other options are 1 upon root 15. At later time t you need to select the expression for the wave function. E to the power minus iota E naught plus E1 t upon 2 h cut, and we will have different topics based questions in today's quiz. 2 sine naught minus sine 1. Clear? Second option is 1 upon root 15. Clear? E to the power minus iota E naught t upon 2 h cut 2 sine naught minus sine 1. Clear? Option C is 1 upon root 15 e to the power minus iota E1 t upon h cut. Then you are going to have 2 sine naught minus sine 1. And now option D is also, once you will get it done, you can mention done in the comments. Okay, but to mention the right option, just wait for that. Together everybody will mention the right option, okay, in the comments. Okay, so you can mention done once you will get it done. The option D is 1 upon root 15 2 sine naught e to the power minus iota E naught t upon h cut minus sine 1 e to the power minus iota E1 t upon h cut. Clear? Now you just need to solve it. You just need to get the answer for this question and mention done in the comments, and let me know once you will get it done. Then we will quickly start the discussion about the right option. Once everybody will get it done. Yes, Subramanyam, this is the first question, and here in this question you are having a wave function at time t is equal to 0 given to you. You just need to find the wave function at any later time t, and that's how you are going to have the expressions given to you in the options. That's very good, everyone. I hope everybody will be able to get the answer for this question in this much time. So you can start mentioning your right option in the comments now, that which option is correct according to you. Okay, just start mentioning whether option A, option B, option C or option D. Which one is correct according to you? Whatever option is correct, you can mention it in the comments. Very good, Kirti. Very good, Anandita. Very good, Merita. Very good, Subramanyam. Very good, Kaku. Very good, Kishan. Very good, Vivek. Very good, Pratiksha. And very good, Barsha. Very good, Ananya. Very good, Nasreen, Rachna, Wafia, and Pawan. Very good, everyone. So this is like a direct concept-based question, you can say, that whenever we are going to have any wave function given to us at any time t is equal to 0, okay, and we want to find the wave function at any later time t, what we need to do, we just need to multiply it with the term that is e to the power minus iota en t upon h cut, where en will be the energy of that particular state with which you are multiplying this term. Okay, so you can see there we had the two states present in the given wave function. One was psi naught, another one was psi 1. So what you are going to do with psi naught, when you are writing this term, you are just writing e to the power minus iota e naught t upon h cut with that. And when you are writing it with the psi 1, you are writing minus iota e1 t upon h cut along with that. That's how you can write it directly, and the right option will be option D. Okay, and if there is someone who is not familiar with the concept that how to get the wave function at any later time t, when you know the wave function at time t is equal to 0, okay, so this is very important. Get to know about it right now and use it wherever required and wherever you need to use this particular concept, so it will be good. Done now. And if you have answered it right, please consider the +5 marks for this question, and if you have answered it wrong, then minus 1.25. if you didn't answer it, then 0 marks. Okay, now let's talk about the next question we are going to consider in this session now. Here is your next question, guys. There is a particle whose mass is m, okay, a particle of mass m. The wave function corresponding to that particle, that is psi x, is equal to a e to the power iota kx. This is given to you, a e to the power iota kx. Okay, now k is a wave vector here. The particle's mass is m and k is a wave vector here. If we are going to consider a as a constant, k is wave vector and a is a constant, m will be the mass of the particle. Okay, in this case you need to find the magnitude of probability current density of the particle. Find the magnitude of probability current density of particle. Okay, now the options are mod a square h cut k upon m. This is option A, and the option B is mod a square h cut k square upon m. Done. Next one. The option C is mod a square h cut k upon 2m. Once you will get it done, just mention done in the comments. Okay, and together we all will mention the right answer, the right option. Now the option D is mod a square h cut k whole square upon 2m. So that's how you are going to have all the 4 options given to you. Okay, and let me know once you will get it done. Very good, everyone. Let's wait for others' answer too. Okay, then together we will start mentioning the right option in the comments. Okay, till then, once you will get it done, just mention done. That's good. Waiting for more answers. and then quickly we are going to start the discussion about it. If you are having any doubt anywhere and something is not clear to you, you can tell me about it. Okay, we'll just consider that point. So here the wave function is given for a particle of mass m, and you just need to find the magnitude of probability current density. Okay, this is your question. Okay, so guys, done. Now you can start mentioning your right option in the comments. Okay, so just mention the right answer in the comments and I will let you know whether it's gonna be right or wrong. So if you have got it done, please mention it in the comments that which option is correct according to you, and we'll start the discussion about it then. That's very good, everyone. Okay, very good Kishan, very good Merita, very good Rachna, very good Shruti, very good Bhafia, very good Prince, very good Subramanyam, very good Pratiksha, very good Ananya. That's good. And what about others, guys? Very good Kaku, very good Pavan, very good Ghanshyam, very good Barsha, very good Nasreen, Kirti, Vivek. Okay, that's good. So guys, the right answer for this question is option A. Those who are saying option A is correct, their answer is correct, and they can consider the +5 marks for this question. If somebody is getting some other option as the correct answer, then they have to consider -1.25 marks for this question. If you are not getting the answer, then you will consider 0 marks. Now let's talk about the process and the steps you have to take to solve this question. Okay, so first of all, let's talk about it, that what is exactly the formula we are having for finding the probability current density. Okay, so guys, here we are going to have the expression for the probability current density. Let's write it on the next slide. So that expression is h squared upon 2mi. Okay, h squared upon 2mi sine and delta. Basically, sometimes we are just going to write it in one single term, but it should be clear to us that how we need to write the complete expression even. Okay, so firstly we'll consider the complex conjugate of sine, then delta sine minus, then just take the sine as it is, but write the delta sine star. Okay, now you know what is the wave function expression given to you in the question. What was that expression? That was a e to the power iota kx. Okay, now psi is a e to the power iota kx, so what will be sine star? It will be a e to the power minus iota kx. Let's write it here. This is the probability current density formula. If somebody was not familiar with it, get to know about it right now. Okay, and use it wherever you want to find the answer for the probability current density. A e to the power minus iota kx del over del x, a e to the power iota kx, okay, minus, just write it, it's gonna be a e to the power iota kx del over del x, a e to the power minus iota kx. Done? That's how you are just going to get it. Now when you will solve it further, what you have to do, you just need to differentiate it. You can write the mod a square outside this bracket, okay, and just simplify it. So when you are just going to simplify it, when you will differentiate this part, what you will get? You will get iota k e to the power iota kx, and from this one what you will get? You will get minus iota k e to the power, that's gonna be again minus iota kx. Done? This is what you will get. Just after the differentiation part, a will be there. Yes, you can even write a, but we are going to write the a common here. That will be h squared and a square. And as in all the options we are having the mod a square present, So write it like this, upon, you can see iota you are getting from this term, also you are getting it from this term. Take iota common, that will get simplified and cancelled out. So you will just get 2m in the denominator right now. And the other terms which you will get within the bracket, that will be, even you are getting k. So you can take k common as well. Then write k here. Next thing, you will get e to the power iota kx into e to the power minus iota kx. When you will solve it, when you are just going to solve the powers, you will get e to the power 0, which means 1. Then plus, again same, exponential terms, when you are just going to consider them together, iota kx e to the power minus iota kx, then 0, it will be what? E to the power 0, which means 1. 1 plus 1 will be what? It will be 2. 2 and 2 will get cancelled out. What you will get finally? You will get h squared k mod a square upon 2m. Okay, that's how you are going to get it. So when you are going to check the options given to you, it will match with option A. So the main thing in this question was that what is the probability current density formula, how we can find it, and what will be the steps we need to follow to get the answer. So I hope if somebody was here who was not familiar with this formula, they have got to know about it now. And let me know, is this clear to everyone? This is the main formula we are using right now to get the final answer. If there is any doubt anybody is having, please let me know about that. And if everything is clear, that's good. We can talk about the next question. So let me know, is everything all right? Are all the things which we have discussed till now clear to every one of you? And if there is any doubt at any point, you can let me know about that. Clear? Can we talk about the next question if it is clear to everyone? Didn't get your comments. Yeah, it's there. Just a second. Yeah. Okay, Subramanyam. Done? That's very good, Priyanjali. Okay, now guys, let's talk about the next question. Now, next question is related to 1D box problem, that is related to other systems we are having in quantum mechanics, and the main system related to which we are going to consider this question is 1D box. Now, the length or the variation or the boundaries values, you can say, that has been given here. That is, it's a 1D box, the first point about this question. It's a 1D box, okay? For which the x is going to vary, or x is going to have the values, the extreme values, minus 2l to plus 2l. Okay, so minus 2l to plus 2l. These are the two values of x. That means that boundaries have been extended from minus 2l to plus 2l. If it is not clear, I'm just going to write it once again. It's plus 2l. Done? Next point. The wave function for this particle is given as psi is equal to psi naught cos pi x upon 4l. The wave function for a particle which is present within this box is given as psi is equal to psi naught cos pi x upon 4l. Pi x upon 4l. With this particular question, we are going to have like different questions with this particular system and the information which is given to you. Done? So the first question I'm going to ask you is the question clear? There is a particle within a 1D box and the box has been extended from x is equal to minus 2l to x is equal to plus 2l. Okay? Now the psi, that is the wave function, is equal to psi naught cos pi x by 4l for a particle which is within this box, okay, about which we are having all the information. Now the first part of the question is that you need to find the value of the normalization factor psi naught. Get the value of normalization factor psi naught. What is psi naught here? The normalization factor. Okay, psi naught is normalization factor. Now the options are root 2 by L, root 1 by 4L. I'm just going to write them. You can even just put the root in the denominator part, because 1 is in the numerator, so that will be just 1. Next, 1 by 2L and root 1 by L. 1 by 2L and root 1 by L. Just try it once and let me know once you will get it done. Very good, Kirti. Very good, Kaku. What about others, guys? As you will get it done, just mention done in the comments once. Then we will talk about the process and the final answer too. But along with this question, this particular information, we are going to discuss more points and more parts of this question you can consider we will have. Very good, Pratiksha. Very good, Pawan. Very good, Prince. Very good, Subramanyam. Very good, Barsha. Very good, Shruti. What about others, guys? Very good, Nasreen. That's good. Very good, Merita. Very good, Kishan. Okay, that's good. Guys, you can start writing your right options in the comments. Okay, and let's see what exactly is that option which you are getting as the right answer for this given question, in which you need to find the normalization factor, which was psi naught. So mention your answers in the comments, whatever option is correct according to you. Then I will let you know whether that is the right answer or not, and we'll talk about it after that. That's very good. Very good. Very good, Kaku, Pratiksha, Vafia, Barsha, Shruti, Kohinoor, Merita, Nasreen, Kirti, Shiparna, then Jaga, then Prince, Subramanyam, Ananya, Akash, Kishan, Rashna. Very good, everyone. So everybody's answer till now is the correct answer, that is option C. We'll talk about it, that how you will be able to get the right answer as option C. But before that, let's take rest of the parts of this question. Then together we will start the discussion about them. Okay. Now, basically here you just need to use the basic property that any wave function which is normalized, it will satisfy the condition, that is psi star psi will be equal to 1. Okay, deta will be equal to 1. So only by checking this condition you will be able to get the final answer for this question. Okay, let's talk about the next part of this question, that what you need to find after getting the normalization constant. So guys, the next point is that you need to find the energy eigenvalue corresponding to this state given to you. Excuse me. Okay, and I'm just going to show you the options for that. But the main question will be that you need to get the energy eigenvalue for this given state. And the options are h squared square pi square upon 2ml square. Option B is h squared square pi square upon 4ml square. This is 4ml square. Then option C is h squared square pi square upon 16ml square. Option D is h squared square pi square upon 32ml square. Let me know once you will get it done. Just mention done in the comments. System is the same system which I have shown you, and you just need to find the energy eigenvalue corresponding to the state given to you in that question, and here are the options you are going to get. Okay, so please let me know once you will get it done that you have got the right answer, and we will start the discussion about it soon. That's good. Very good, everyone. Okay, so now you can start mentioning whatever option is correct according to you. Just mention it in the comments whether it is option A, B, C or option D. Okay, you can directly mention it in the comments and we'll talk about it. Very good Kohinoor, very good Anandita, very good Pratiksha, very good Barsha, Kirti, Kaku, Kishan, Shriparna and Nasreen, Rashna, Prince, Marita, Ananya, Subramanyam, Shruti, Jaga, Vivek and Bafia. Very good everyone. Till now everybody's answer is correct. That is option D. This will be the correct option, and the main point in this question was where you have to be more careful before answering it, that is the length of the potential well. So it was extended from -2L to +2L. So overall that means origin, that is 0 will be there and 2 this side and that side. So if you will be careful about the length, you will be able to get the right answer. So it's gonna be 4L. Okay, so 4L square, you will get like 16 as just a square of 4, and 2 will be in the formula 2. 16 into 2 will be 32. That's how you are going to get option D as the correct option. Now, the next part for the same question is that you need to find the expectation value of P square in this same state. Okay, get the expectation value of P square, that means momentum square for the same state. Okay, I'm just going to show you all the options. So next question is expectation value of P square in the same state, and the options are zero, h square pi square upon 32L square. This is h square pi square upon 32 ml square. ml square. Then you are going to have h square pi square upon 16 ml square. Option D is, sorry, that's just L square will be here. Then option D is h square pi square upon 8L square. So the main question is that you need to find the expectation value of momentum square. Okay, in this case, once you will get it done, just mention done in the comments and we will start the discussion about the point that what will be the right answer for this question. Very good everyone. Okay, so let's wait for everyone to solve it and quickly we will start the discussion about the exact option which will be the correct one. Till then, let's wait for everyone to complete it. Okay, and as you will get it done, just mention done in the comments and we will soon start the discussion about it. That's good, that's good, that's good. Okay, so guys, now you can start mentioning your right option in the comments, that which one is gonna be the right option according to you. 0, h square pi square upon 32 ml square, h square pi square upon 16L square, h square pi square upon 8L square. So which one will be the correct option according to you? Just mention it in the comments. Very good Pratiksha, very good Kirti, very good Barsha, very good Nasreen, very good Kaku, very good Kishan, very good Wafia, very good Subramanyam, Marita, Prince, Firoz, Anandita, Pavan, Ananya, Utsav. That's good, good, good. Very good, Shruti. Okay, very good, everyone. So basically, the right answer for this question will be which one, guys? What do you think? according to you, because in the options there are different answers too. So the right answer for this question is option C. Those who are getting option C, their answer is correct and they can consider the +5 marks for this question. Okay, and those who are getting any other option as the correct option, they will have to consider -1.25 marks because that's gonna be the wrong answer. Okay, so now let's talk about it, that how you will be able to get this thing. We know in general when we want to find the expectation value, as it is a 1D box case, the wave function we consider as a normalized wave function. Also in general, the expectation value when we need to find for any operator, then we are having the formula for that. Let's say the expectation value of p square. So you will just have to consider this formula. Okay, that means whatever operator will be there, you just need to put it at this place and get the expectation value of that operator. Now the point is, as it is a 1D box, the wave function which you are going to get in this 1D box case, okay, that will be normalized wave function. So denominator part you will take equal to 1, because for the normalized wave function, this Dirac notation, when you solve for any normalized wave function, it will always be equal to 1. Okay, next thing, if we are going to talk about the numerator part, to solve it further, you need to know about the expression for p square. Okay, so what is going to be p square? That will be minus h squared square d2 upon dx square. P square will be minus h squared square d2 upon dx square. Done. Now you can just put it at that place, okay, and you can solve it by taking the integration. How? Let me just show you. Integration sine star. What is the wave function given to you there? That was cos. In terms of cos you were getting it, and after normalizing that wave function you were able to get it as it was basically 1 upon root 2l, okay, cos pi x upon 4l. This is what you will have. Done. So when you are just going to further solve it or simplify it, what you will get, let's write it here. See, you are going to get it 1 upon root 2l, and let's take its square. This was the normalization constant you have got. Then cos square pi x upon 4l. Done. Next thing, you are even having, so we have to write it one by one. Why? Because the operator is in between. So write cos pi x upon 4l, then minus h squared square d2 upon dx square, okay, then write once again cos pi x upon 4l. Why? Because this operator, the second order derivative, will operate on this cos term, okay, not for the first one. So if you are going to consider it in this manner, that you are writing or multiplying both the cos terms initially and then you are operating the differentiation operator, your answer may get wrong, okay, and there are great chances that it will get wrong. So what you have to do, just operate the second order derivative here, then the limits of integration which you have to consider will be minus infinity to plus infinity. Okay, solve this integration. Once you are going to solve it completely, your answer will match with option C. Just this is what you need to do to solve this question. Yes, Kaku, you can even do it in this way. Subramanyam, the mock test analysis session today we will have, that is a special class at 7:30 p.m. okay, and tomorrow a special class, as like today is the mock test analysis session, but tomorrow we'll have our special class, okay, at the same time like we are having this session today, because tomorrow you will not have the live quiz session but a special class at this time, 3 o'clock. Firoz, because that is given in the question. Also one more thing, when the symmetric potential well is given to you, you have to be careful about the state for which you are writing the wave function, like n is equal to 1, n is equal to 2, n is equal to 3 or 4, because as per the state or the value of n, the wave function expression will get changed. Whether you will take cos there or you will take sine there, it will be different, okay. So there, if it is not given anytime for the symmetric case, be careful about it, that what wave function you have to consider. But if it is given, that's too good. Okay, now done. Any other doubt anybody is having in this case or in any of the questions? This one, before this we have considered this question. So just to get the normalization factor, what you have to do, you have to take the psi star sine d tau is equal to 1. And what is the psi expression given to you? This one. Okay, so when you are just going to put it here, you will get sin naught square, then cos square pi x by 4l, because it is just the function of x, okay, or 1D case, so write dx is equal to 1. Now what you have to do, normally just even you by equating it with 1, you can get your answer. Okay, now to integrate, what you have to do, you have to use the formula for cos 2 theta, because that is 2 cos square theta minus 1. Get the value of cos square theta from there, put it at this place, then integrate, and the integration limits you have to consider from minus infinity to plus infinity. Okay, replace it. You know cos 2 theta is equal to 2 cos square theta minus 1. So now how you can replace the cos square theta? That will be cos 2 theta. Theta is what? That is pi x upon 4l here. Done. Cos 2 theta plus 1. So write plus 1 here upon 2. So I'm just going to take that 1 upon 2 term at this place. Dx is equal to 1. Once you will integrate and simplify it, you will be able to get the value of sin naught. Even take the sin naught outside the integration. Okay, that's how you can just take it and simplify and get the answer. Done? Because that's a constant here. So let me know, are all the questions clear to everyone, the discussion we have done till now? Also one more thing guys, let me know till now how many total questions we have done, and according to that, each question 5 marks. Please mention your marks for these many questions which we have completed till now in the comments. Also, if you have answered any question wrong, just consider minus 1.25 marks for that and mention the total marks in the comments after that. I'm just going to wait for your final answer. Okay. Yeah, 5 questions. The total marks you are getting out of 25. Okay, you can start mentioning them. Very good Barsha, very good Kirti, very good Pratiksha, very good Merita, very good Kishan, very good Ananya. What about others? Very good Subramanyam, very good Kaku, very good Firoz, very good Rachna, very good Shruti. And guys, if your any of the question was wrong, okay, and you got to know about the concept involved in it, so focus on that part. It's gonna be helpful, okay, in the exam, in the main exam. If you are going to get any such question, you will easily be able to manage it and get the right answer. So that's good. Very good Priya, very good Nasreen, very good Wafia. What about others? Very good everyone. Pawan, most probably in November. ठीक है, चांसेस हैं, बहुत ज़्यादा चांसेस है कि नवंबर में हो सकता है आपका एग्जाम. प्रिंस, टुडे यू विल मेंशन, सो इट्स गोना बी, आई थिंक यू आर आल्सो गेटिंग 25. Okay, so guys, let's talk about the next question. Are you ready for the next question? Can I give you the another one? Everybody is ready for getting the next question. It's gonna be a little bit different one, but yeah, if you know about it, that's good. But if you don't know about the concept involved, you will get to know about something new then. Done? Here's the next question we are going to have. So the question is, a particle is in the normalized state sign, okay, which is a superposition of the energy eigenstates. I will just write it here. A particle is in the normalized state sign. Is in the normalized state sign. Done? Which is a superposition If something will not be clear to you at any point of time, you can tell me, okay? Just mention it in the comments. Okay, so superposition of the energy eigenstates that's gonna be E naught which is given to us 10 electron volt okay. Next, and E1 which is equal to 30 electron volts. Clear? The average, guys, is everything all right? Is everything all right? Kaku, the date has not been declared yet. So once we will have the official information about it, then we can finalize like, yeah, that is the particular date when we will have the exam. Okay, that's good. So the next point. So after knowing about these energy values, we are going to have the question, the average value of energy, okay, of the particle in the state sign. Average value of energy of the particle in the state sign is 20 electron volts. The state sign is given as, you need to find the state sign itself. Okay, I will just show you the options on the next slide. So this is the statement given in the option, in this question. It's like a particle is in the normalized state sign, which is a superposition of the energy eigenstates E0 and E1. The energies corresponding to these states have been given. After this, the average energy of the particle in the state sign is 20 electron volts, okay, and you need to get the wave function sign. Okay, now the options are, it's visible clearly here, we can even shift it a little bit. One upon 2 E0, the energy value along with the E0 even you can mention, that is 10 electron volts, which is even given in the question itself. Root 3 upon 4 E1 option B is 1 upon root 3 E naught plus root 2 upon 3 E1. Then you are going to have the next option C is 1 upon 2 E naught plus, sorry, it's minus root 3 upon 4 E1. Option D is 1 upon root 2 E naught minus 1 upon root 2 E1. Okay, these are the options given to you. Now once you will get it done, please mention done in the comments that which option is correct according to you, and we will soon start the discussion about it after that. So let me know once you will get it done that which option is correct according to you, and I hope that the statement which we have discussed on the previous slide will be clear. Okay, so this was the information given in the question, and here you are going to have the options. So let me know as you will get it done and which option is correct according to you. Waiting for your answer, and then we will start the discussion about it. Very good, Pratiksha. What about others, guys? Very good, Subramanyam. Very good, Kirti. Very good, Shradindu. Very good, Feroz. Very good, Marita. Very good, Ananya. Very good, Kaku. Okay, that's good. What about others? Waiting for more answers. Okay, and soon we are going to talk about it, like which option is correct. So let's wait for everyone to complete it. Very good, Rashna. Very good, Kishan. Okay, that's good. Very good, Shubkaran. Okay, so guys, now you can start mentioning it in the comments that which option is correct according to you. Option A, option B, option C, or option D. Which one is correct? Okay, so write it in the comments which one is gonna be the right option according to you. Very good, Kirti. Very good, Kishan. 2 answers till now, waiting for more. Very good, Pratiksha. Very good, Subramanyam. Very good, Feroz. Very good, Ananya. Very good, Shradindu. Very good, Marita. Very good, everyone. Okay, what about others? Just few answers till now, waiting for more. Very good, Rashna. Okay, that's good. Clear. So guys, basically for this question, very good, Midhun. Very good, Kaku. For this question, the right answer is option D. If you are getting the option D as the right answer, that's correct, and you can consider the +5 marks for your answer for this question. If you are getting any other answer as the correct answer, then you have to consider the -1.25. If you didn't get the answer for this question, then you will consider 0 marks for it. Okay, very good, Pawan. Very good, Shruti. Very good, everyone. Most of the answers are correct, but we will talk about it, that which one exactly is the right. That is option D. So if you are getting option D as the right answer, your answer is correct, and you can consider the +5 marks for this question. Then let's talk about it, how you will get the option D as correct option. Okay, now Let's talk about it, guys. What is the average energy value given in the question? Please let me know in the comments once. What was the average energy value given to you? They have given you the value of the average energy in the question. That was 20 electron volts. Okay, that was 20 electron volts. So that was what the average energy. Let's write it here. Let's just talk about the process. What are the steps you will take and how you will get the final answer. After that, they have given you the information. Even in the question, they have given you the information that E0 is having the energy 10 electron volts and the E1 is 30. Okay, so 10 and 30. So E0 10 and E1 30. Done. Now the point is, we know that the basic formula for the average energy case we even consider as, if anytime we are going to have the wave function as a superposition of two states. Okay, like you can see everywhere in every option, it's like the two functions present. So we can consider it a kind of like the two different states are involved in this. We prefer to write the average energy formula like this: summation over n, En, Pn. That is, Pn is the probability here and En is the corresponding state's energy. Done. Now, there are two states everywhere: E0, E1, E0, E1, E0, E1, E0, E1. Okay? What you will do? Just write E0 into P0 plus E1 into P1. Clear? Now the point is, what is E0? That's 10. What will be the probability of getting the particle in this E0 state as per option A, B, C and D? You can check. But let's check for option D right now, because you can see when you are going to consider the denominator part of the probability, that is the sum of square of the coefficients. Okay, that will be 1 upon 2 plus 1 upon 2, which is 1. So you will just get it 1. It is a normalized state. Even this is normalized. Even this one, let's just check it out. I think this may not be normalized, but that is normalized. You can check it. If the sum of square of the coefficients will be 1, it is normalized state. Okay. Now, if I'm going to talk about this P0, for this case, it will be 1 upon 2 plus E1, that is 30 into then P1, what will be that? Again 1 upon 2. Okay, when you are just going to check it, you will get 5 plus 15, that is 20 electron volts. Okay, and they have given you the average energy must be the 20 electron volts. You are getting it from here. Let's check it for the other cases. Let's check it for option B. Okay, so option B, just replace the probability, because which is normalized one, it will be easy for us to write the probability quickly and to check it what exactly the value of average energy we will get. Okay, this is 15 I have written here. Now the point is 10 into 1 upon 3 plus 30 into 2 upon 3. So will you get exactly 20 from there? Just check it and let me know for option B what value you will get for the average energy if you are just going to take the option B as a wave function expression. So let me know. Option B will give you the value for the average energy as, just mention it in the comments. Once you will get the value, whatever value from the option B you will get. Right, Kaku, option B and option D will be the normalized ones. When you are considering that option B is the wave function which you need to find, okay, or for which the average energy is given. So what is the average energy exactly you are getting from option B? Two different answers. What about others? Robert is getting 35, Rose is getting 5.3. Let's wait for others to get sure about it. What about others, guys? Waiting for more. What about others? 20.33. Everybody is getting the different answer here. 3 different answers till now. 70 upon 3. Is it 20? Okay, my question to you is it 20 or not? Is this 20 or not? Just because we need to have the average energy 20. Is it equal to 20 exactly? Because everybody is getting the different answer. But I think nobody is getting 20 exactly. Okay, when it is not 20, in that case, you will get to know that okay, that cannot be the wave function which we need or the required wave function for the given question, and that is not a right answer. Okay, similarly you will be able to check for other options too, and that's how you should be able to get it, like okay, which option is correct and which is exactly giving you the 20 as the final answer. Done. Even there will be detailed process to solve it, but it will be very much time taking, so it's better to consider this approach that we are taking the help of the options, we are checking them and getting the answer quickly. It just requires a quick calculation, okay, and good command in the calculation part, and you will be able to get the answer easily for any such type of questions. So guys, now you can mention your final marks in the comments out of 30, that how many marks you are getting. If you answered any question wrong, then minus 1.25 for that question. If you have answered it right, then 5 marks. If you didn't answer it, then 0 marks. Let's talk about the Unacademy Plus subscription till then, and you can keep on mentioning your marks in the comments, total marks out of 30. Very good Subramanyam, very good Kishan, very good Marita, very good Shruti, very good Kaku, Rashna, Ananya and everyone. That's good. Also guys, one more thing, now our live quiz sessions or the YouTube sessions will have in October. Okay, so tomorrow at the same time we will have a special class, that means at 3 o'clock. You can join that special class from the Unacademy learning app as well. Okay, it will be even important one and will help you to prepare very well for your upcoming exam. So you can join that special class, and for the next month the YouTube sessions timings and everything you will get to know soon. Okay, and thank you so much everyone for joining this session, and very good everyone, you all have done well, and very good Shruti, Kaku, Rashna, Ananya, Kishan, Shradindu and Pratiksha. Very good Pawan. Okay, so thank you so much everyone for joining this session. And guys, if you want to attend the more regular live classes by all the top educators we are having on Unacademy Plus for your upcoming CSIR NET Physics exam preparation, then you can take the Unacademy Plus subscription. Soon on Unacademy Plus we will have the revision courses which will start, and along with that guys, there are going to be many other courses. The batch courses will be going on. This batch course has started in this month, that is, it has started from 5th September, but if anybody will take the subscription right now, even they will be able to get the recordings of the classes they have missed, and they will be able to cover up each and every part and the session, the discussion we have done. Also, a new batch course will soon start on 1st October. So if you want to attend the regular live classes for this batch course, even you can take the Unacademy Plus subscription, and along with this batch course you will even be able to attend the live classes of other courses for your upcoming exam preparation by all the top educators we are having on Unacademy Plus for your upcoming exam. Also guys, whenever you will take the Unacademy Plus subscription, you can use and apply the referral code, that is Anjali Arora. As it is mentioned here, no space in between, the spelling should be same. That's how you can write it, apply it and get the 10% discount in the total Unacademy Plus subscription amount. One more thing guys, at this point of time many students are going to have a question, is it okay, will it be good like if you are taking the subscription right now? So guys, yes, it will be good for you, as you will be able to do the proper revision. You will get to know about many important things in just remaining time before the exam. So it will surely help you to boost up like the concepts, to know about the important points, to prepare well in the remaining time. Even if let's say any course is going on and you are taking the subscription right now and some of the classes of that course have already been conducted, then you will be able to get the recordings of those sessions. That's how you will be able to cover up each and every part. Okay, so you will not miss anything. Clear? So thank you so much everyone for joining this session. Thank you. I hope each and every point which we have considered and discussed in today's session will be clear to all of you. Thank you. And whenever you are going to take the Unacademy Plus subscription, you can use and apply the referral code, that is Anjali Arora, as it is mentioned here, to get the 10% discount in the total Unacademy Plus subscription amount. Thank you everyone for joining this session. Thank you. Subramanyam, we will soon have the quizzes in the app too. You will get to know about it when they will start. Okay, so thank you everyone. Robert, many courses are going on right now. You can just check the courses going on Unacademy Learning app. You will get to know about them. Done. Just a second. Rimpy, you can get them, like, get to know about them when you will be regular in the sessions. Most probably now, see, in the from the 1st October or just in October, we'll soon have the sessions, and you will get to know about them, so you can just be in touch and be regular with the sessions. And one more thing, tomorrow at 3 o'clock we will have our special class, as I have informed you about it. So yeah, when you will be regular in the classes, you will keep on getting the information about the classes too. Done. Thank you so much everyone for joining.